So my introduction to soil databases, the SERGO database, was about 5 years, and I hated them because I find them really convoluted, really big, very difficult to work with. And I'm not a GIS expert, so I can't like quickly write scripts and whatnot. So just to give you an idea, by the way, how many of you have really worked with the SERGO databases before? Okay, a few poor souls. All right, so let me tell you how these databases are organized. So the SERGO databases are basically maintained by USDA, Natural Resources Conservation Service, NRCS. So when you go and download these things, you get a shape file, and you're like, oh, great, I know where my soils are, and I'm going to quickly, go and click my shape file, and then I'll see all my soils. But it turns out that you click these shape files, and you don't see anything except a map unit ID. That's all it is, right? So what is georeferenced is just a polygon, and there's no data attached to that polygon except an ID number, a map unit ID number. So, and these SERGO databases generally come, county by county, sometimes multiple counties, sometimes big counties are divided into smaller sections, but generally, you download, a specific county, soil database for a specific county, and then when you plot, visualize that in ArcGIS, you see these map units, okay? Like, thousands of map units that you can visually see and color and stuff, but the problem is there's no data attached to them. There's no soils, nothing. So when you read their, database structure, what you realize is that each of these map units, which again can be thousands of them in a single county, are divided into what they call components in the horizon, right? So the components have some data attached to them, but generally not the data that we are after for at least IWFM. The problem with the components is that what percentage of a particular map unit is made out of, let's say, component A, but you just don't know where that component is, right? So spatially, you don't know. You just know that map unit, whatever, is made out of 30% of component A, 50% of component B, whatever. And then out of each of these components, in the vertical are divided into what they call soil horizons. And that's where our soil properties actually listed. They have a table called C horizon, I think. And in those, they basically say, okay, this particular component has, let's say, 5 horizons. The thickness of each of these horizons is this. And then for this horizon, saturated hydraulic conductivity, there's a representative saturated hydraulic conductivity, and there's a low value and a high value. And they actually have a lot of different types of data for the horizons, including things that we are interested in. So to be able to do any kind of geospatial analysis with this data, what you need to do is somehow you need to take this tabular information and bring it up to the map unit level. Right? So these are all tabular information. So what you have to do is you have to somehow maybe average these out, or do some kind of processing over the horizons, and then come up with some, let's say, representative hydraulic conductivity for component A, component B, and so on. And now you know the percentages of these components in the map unit, and maybe you can use those percentages as weighting factors to come up with a single hydraulic conductivity for your map unit. Now suddenly you have thousands of hydraulic conductivities in your map, right? Now when you click on the map, you can see your average hydraulic conductivity, average field capacity, so on and so forth. But this process is very painful because they have this averaging, because they have missing numbers, and it's just painful. So after working on this for 5 or 6 times, and every time realizing that I missed something, I got really frustrated, so I basically wrote a code to access this Sergo database and do that averaging for me, at the same time weeding out the problems, like missing the data or whatnot. So from that came this tool that we call Soil Data Builder. So you can go to the IWFM website. We have a link there called Support Tools, and when you go there, including Mesh Generator, we have multiple tools listed there. One of them is called Soil Data Builder. So you can, when you install that, I think I did install it. It's just a very simple tool. What you do here is you point to a Sergo database, right? Let's say here nearby we have Yolo County or Sacramento County. Let's say I downloaded the Yolo County database, and these come in as Access databases, Microsoft Access databases. I point to that, and then I just say, okay, just process that for me. So what this tool is doing all this averaging in the vertical as well as in the horizon, and getting the data that IDC is interested in, not everything, and creating these text files. They're going to be comma delimited text files. All right, so that was successful. Okay, let's see. I think I was actually in the other one. Okay, so yeah, so these are the text files that it created. It created a available water content, which is equivalent to total available water, which is really the difference between fill capacity and wilting point. Hydrologic group, based on the curve number method, A, B, C, D. KSAT, saturated hydraulic conductivity. We have the porosity, pore size distribution index, soil depth, texture. IDC or IWFM doesn't use the texture data. Is it clayey, loamy, whatever. But texture tends to be used a lot, right? So if you want to do any kind of analysis, you can actually use this texture data to do your own analysis. Soil moisture content at third bar, 1/3 bar, that is basically equivalent to field capacity, is it? Yeah, field capacity. 10th bar is, no, I heard that in some places they use 10th bar as the field capacity. 15 bar is the wilting point. Okay, so let's look at some of these. Let's look at the KSAT. Okay, again, this is just a comma delimited file. You have the map unit key that is coming from the Sergo database, the low end of the saturated hydraulic conductivity, the representative value, and the high value. So you can at least bring this into GIS, join it to your map units, and do whatever you want. But it turns out that bringing this to GIS and doing whatever you want is another pain in the neck. So the next step was to try to relieve that pain in the neck a little bit more, and we basically came to this other tool, which basically wraps this tool called Soil Data Builder with GIS. So here's the problem. Not the problem, but the source of the neck pain. So you have your county, okay, and you have your, I think these are map units. No, sorry, Okay, what are we looking at here? Oh. Okay, this is what we're... So you basically developed your tools. I mean, you ran the soil data builder. You brought all those tables into your GIS. Now you have to do joins and whatnot. But the issue here is you want to somehow intersect your grid. For instance, our goal is to come up with representative soil parameters for each of our cells, right? So now the workflow would be bring all that data in, and then join them to your map units, and then intersect your map unit shapefile with your grid, and then somehow come up with an other average for your cells, right? Because your cells most likely will cross multiple map units, so you're talking about another averaging this time based on map unit intersecting with your cell. And this problem is even worse if your grid lies over multiple counties, which means now you have to deal with data from two separate Sergo databases. So that's another pain. So we basically decide, okay, can we automate this in GIS environment? And that's how we ended up coming up with the soil data builder with GIS tool. So let's close this up. Okay, and again, when you go to the support tools link in the IWFM website, you will also see that. You download it, you can, when you install it, it comes up as an IWFM SDB Soil Data Builder GIS tool. Okay, so what I'm going to do is I'm going to bring in some, first thing that I need to see is whatever domain that I'm dealing with, which counties does it intersect, right? Which Sergo databases do I need for this exercise? So what I'm going to do is I'm going to bring in some counties and bring my grid. Let's see. Okay, I'll bring the California counties. Okay, and let's say that this is my grid. Okay, so this is some random model. I generated a grid, and what I need is soil parameters for each of those cells. And by the way, your polygons don't need to be IWFM grid. You know, calcium actually. For calcium, we have these boundaries based on source of water. You know, are these areas living purely on groundwater, living purely on surface water? So there are these boundaries, and we actually ran this tool for those boundaries too. It doesn't have to be a computational grid. Okay, so what I'm going to, the first step is to figure out which counties my interest area intersecting. So what I'm selecting here is, and I apologize for the very small font, but what I'm doing here is I'm telling the tool which is my county layer and which is my area of interest. In this case, my area of interest is the elements shapefile, and my county layer is called California counties. And when it selects these counties, I want which field in the county layer to be listed, you know, and I want the county names to be listed. And I will say, choose that. Okay, so what came up is Contra Costa, Napa Valley, Solano, Sonoma, and I think Yolo. Okay, so now I have my county information. I go to NRCS website. download the Sergo databases for those counties. And now I need to point to those Sergo databases with this tool so that it can grab the data from those databases and do its job. So let's go and Contra Costa, was it Contra Costa? Yeah. Okay, Napa. Solano. What else? Sonoma. And YOLO. All right. Now what I'll do is, the next step is to have this tool run the previous tool on each of these Sergo databases and create those text files so that I can later bring them into my GIS environment and do the joining and merging and stuff like that. So that's the next step. Yeah, so now it's basically operating on the Contra Costa Sergo database and doing exactly the same thing that we did in the previous tool without the GIS part. So for those counties, when NRCS, for those ones that NRCS divided into two, like Shasta County is one, I think, because it's really big. When you do this intersection, this tool will say, well, you know, your model is intersecting with Shasta County, period. There's no two Shasta counties. In that case, you can actually use this plus sign and add the, you know, like second Shasta County Sergo database manually. I guarantee you, if you did this manually, this would take it would take it longer than this. All right, so that step is done. Now, the next step is to bring all these information into the GIS, do the joining, do the merging, and then creating a big giant shapefile, and then intersect it with my grid, and then get the average parameters for each of those cells. So for that, I go to the next tab here, which is the merge and report. So I need to choose an output file. Output folder, I'm sorry. Let's choose our workshop, demos, stbgis, output, okay. And then which layer do I want to intersect with this tool? I want to, with the Sergo databases, I want the elements layer, and then which field do I want to list all my soil parameters. Basically, I want to list each of these for my element IDs, right? Element 1, element 2, element 3, and whatever parameters they are. So it's already selected, element ID. And then let's go and report. Now, as you can see, it's bringing all those tables now, right? And then in the background, it will do the joining, it will do the merging, and then the intersection. And I keep telling people, we did this for the parameters that we were interested in for IDC. But if you have a project, it doesn't have to be an IDC or IWFM project, and you need some data from the Sergo databases, it's just not processed by this. You can send me an email, and it's very quick to basically add another parameter into this tool to process. Actually, my colleague Devinder, about a year ago, he had a project, and I guess you needed its soil depth, right? And there's one parameter there. It's a soil depth parameter. IDC doesn't necessarily use it directly, but it was very easy, like 10 minutes or something like that, to put that parameter in the tool and then get you the information that you needed. I don't know if you ended up using it, but so I heard organic matter maybe, I don't know. So yeah, let me know.
Is there a documentation for how to use this tool?
I'm sorry?
Is there a documentation on the website on how to use this tool?
I think if you go to the help right here, hopefully there's going to be a PDF file. Let's check afterwards. It's not grayed out, so I'm hoping that there's a PDF file hidden behind it. That's the user's document. Yeah, when I tried to do this by hand, I think it took me 3 weeks. As I said, I'm not good at GIS, so it was a lot of do something, bring it to Excel, check it, bring it back to GIS, do something else, bring it to Excel. All right, now it's writing the parameters for each element. All right. So now I can go to my, okay, first let's look at, okay, yeah, so there's a user's manual that comes with the tool. Okay, let's turn off some of these layers here. So okay, so this is my model soils now. Let's, for instance, look at the distribution of hydraulic conductivity maybe, right? The representative hydraulic conductivity. Graduated colors. Well, let's try this as it is. Would that work? I forgot. Wait, where did that go? Okay. And let's make this like 11 or something like that. Okay, so this is the distribution of representative hydraulic conductivity. And so anyway, so I think this is pretty useful. I mean, we used it for several projects. I helped somebody out in Oregon to use this tool, so it seems pretty useful. Any questions on this?